Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 19, Cones and Spheres. Classwork exercise 1. Note, figures are not drawn to scale. 1. Determine the volume for each figure below. Write an expression that shows volume in terms of the area of the base B, area of the base B, and height of the figure. So we want to show volume in terms of area of the base B and height of the figure. Explain the meaning of the expression and then use it to determine the volume of the figure. So what we have here is a circle, which is our base, with a radius of 6 inches. And we have a height of a cylinder that is 10 inches. Okay, so volume equals the base area times the height. So there's our formula, V equals base times height. So the volume equals, and now we're going to substitute in our base area for the formula of the area of a base, and it's a circle, and the area of a circle is pi r squared. So now I replace my capital B with pi r squared. So that is the base area, B, and then we multiply that by the height. So now we substitute in our givens. So volume equals pi times the radius, 6 squared, times the height, 10. So volume equals pi times 6 squared. Well, 6 squared is 36, and 36 times 10 is 360. And we just generally write the number in front of the term of pi. We don't say pi 360, we say 360 pi. So the volume of the cylinder is 360 pi inches cubed. Okay, part B. Write an expression that shows volume in terms of the area of the base B. The area of the base B is, again, a circle. This is our base with a radius of 6. And the height of the figure, which is this right here. The height goes from the point to the center of the circle's base. That is h. Explain the meaning of the expression and then use it to determine the volume of the figure. Okay, so volume equals, and the volume of a cylinder is pi r cubed times height. But the volume of a cone, we're cutting off 2/3 of it. So if you were to see this as a cylinder, this is 1/3, this is 1/3, or it's all the way around, so it's 2/3, and the part that's left over is 1/3, and that was shown in prior lessons, probably last year or earlier this year. There is also a video online that explains that. But the volume of a cone is 1/3. Well, actually, first of all, yeah, let's say 1/3 the base times the height. Then we substitute in, so the volume now is 1/3, and our base is a circle, so that's 1/3 pi r squared times height. So then we substitute in all of our givens. So it's 1/3 times pi times the radius, which is 6, squared times the height, 10. So the volume equals 6 squared is 36 times 10 is 360. So it's 1/3 times 360 pi. This can also be simplified. So 1/3 of 360, 3 goes into 3 once, 3 goes into 6 twice. 1/3 of 360 is 120. So the volume of this cone is 100 pi inches cubed. Number 2, A. Write an expression that shows the volume in terms of the area base, B, and height of the figure. Well, the base, in this case, is 12 by 12, so it is a square. Okay, so its volume equals the base area times the height. So then we substitute in our base area formula, which is a square, and the volume and the area of a square is side squared times height. Then we substitute our givens. S is 12, so it's 12 squared times our height, 10. So the volume equals 12 squared is 144 times 10. So the volume is 1,440 inches cubed. Okay? B. The volume of the square pyramid shown below is 480 inches cubed. What might be a reasonable guess for the volume? What might be a reasonable guess for the volume of a pyramid? All right, well, they repeated themselves. What makes you suggest your practical guess? Okay, so what is this? Well, it's a pyramid that's cut away from the same base size as this, and since a cone is a third of a cylinder, then I would assume that a pyramid would be a third of a square pyramid, or a square prism. So I would say it'd be 1/3 of this. So my guess would be a third of 1,440. So if I took 1,440 divided it by 3, three goes into 14 4 times. 3 goes into 24 8 times. So my guess would probably be the volume is 480 cubic inches. So let's just see. So volume equals 1/3 base times height. So volume equals 1/3 what we got up here, S squared times height. So the volume equals 1/3 times 12 squared times 10. So the volume equals 1/3 times 144 times 10. Volume equals 1/3 times 1,440, and I've already calculated that up here, and it is 480 inches cubed. Example 1. State as many facts as you can about the cone. Okay, so what can we say about this? Well, we know that the area of the base equals pi r squared. We can find circumference of the base, and circumference equals 2 pi r, or circumference equals pi d, depending on what we're given. Volume of the base, or of the cone, of the whole cone now, the volume of the cone would be 1/3 pi r squared times height. Where this is S, this is H, this piece here would be the radius, and this piece here would be the diameter. Okay, exercise 3 through 10. What is the lateral length, slant height in other words, of the cone shown below? So the lateral height is usually depicted by L, and the lateral area is, or the lateral side would be this right here. So if we want to find that, I see that this is a right triangle. So the Pythagorean theorem says that a squared plus b squared equals c squared. And a can be 4 and b can be 3, or a can be 3 and b can be 4, but the L has to be c. So I'm going to say 4 squared plus 3 squared equals L squared. 4 squared is 16, 3 squared is 9. Equals L squared. 16 plus 9 is 25 equals L squared. And if I take the square root of 25 and I take the square root of L squared, then I get L to equal 5. Okay, now it says determine the exact volume of the cone shown below. So you always start a problem with the formula. Volume equals 1/3 base times height. Substitute in what you know. Okay, and we need to know what the base is. The base is this circle here with a radius of some length, but we don't know the radius yet. So I have to go off to the side and do a formula for my, I can't find the base area unless I know the radius of the base, and I don't, but I do know the height of the base, and I know the lateral length or the slant height. So it's a right triangle just like this problem up here, and I always write the formula first. A squared plus b squared equals c squared. I'm doing the Pythagorean theorem because I have a right triangle. In this case, a is 6. The base is my radius, so I'm going to write r squared equals 9 squared. So it's always important to write the formula so you substitute correctly. So in this case, we know the hypotenuse c, but we didn't know the base b. So now 6 squared is 36, plus radius squared equals 9 squared, which is 81. If I subtract 36 from both sides, then I get r squared to equal 45. Therefore, when I take the square root of r squared, and the square root of 45. So r squared is the square root of 45, or r squared equals 45, so r equals the square root of 45. I will leave this in radical form, or actually I could leave it as r squared, because our formula is volume equals 1/3 base, then the base is a circle, and the base is pi r squared times the height. And since I need an r squared, I have r squared here, so it wasn't necessary for me to find the radius, but it is the square root of 45. But I need r squared, which is 45. So now when I finish this, I get v equals 1/3 pi times 45 times the height, and this is my height, 6. I'm going to simplify here first. 1/3 of 6 is really easy. 6 divided by 3 is 2 pi times 45. So 2 times 45 is 90 pi, and it doesn't give us any measurement, so I'd say units cubed. Number 5, what is the lateral length, slant height of the pyramid shown below? Okay, so first I'm going to label this so you know what part we're looking for. It is actually this length right here. That is our slant height L. Okay, so that's our L. All right, so we have a right triangle here. We know its height is 8 inches. We know its base is 4 inches. So all I need to do is the Pythagorean theorem. a squared plus b squared equals c squared, where a is either 8 or 4, doesn't matter. 8 squared plus 4 squared. What does matter is your hypotenuse, which is our slant height, L, is our c. So I'm going to turn that into L squared. 8 squared is 64. 4 squared is 16. 64 plus 16 is 80. So therefore, if I take the square root of 80 and the square root of L squared, then I get L equals the square root of 80. Now it says give an exact square root answer, there it is, and an approximate answer rounded to tenths place. Well, the square root of 81 is 9, so I know that this is 8 point something. So my approximation is going to be L is approximately 8 point something. Let me get my calculator, and it's probably really close to 9, so it's probably 8.9 or 8.8, but let's check. So I turn my calculator on, and I take the square root of 80, and I get 8.944, and it says round to the tenths place, and the hundredths place is a 4, so it doesn't get rounded up. It is 8.9. So the answer is exactly L equals the square root of 80, which is an approximation of 8.9. And I didn't finish. Inches. And that's square root of 80 inches. Number 6. Determine the volume of the square pyramid shown below. Give an exact answer using a square root. So, my slant height, L, is 2. Or that's my C. My B is 1. I don't know my H, which is my A. So this is a Pythagorean theorem again, and we want to determine the volume. But first I have to find the height. So area equals, Pythagorean theorem, A squared plus B squared equals C squared. I don't know A squared, that's my H. B squared is 1. And my slant height is 2. So H squared, 1 squared is 1, 2 squared is 4. So subtract 1 from both sides to solve for H, and I get H squared equals 3. If I take the square root of H squared and the square root of 3, then I get H equals the square root of 3. Okay, so I just found my height. Now I use the formula for volume of a pyramid, and volume equals 1/3 the base area times the height. So the volume is 1/3. My base area is a square. And since this is 1 from the center over is 1, then the whole length of one side would be 2. So this is a 2 by 2 base. So my base area is S squared, because it's a square, times the height, which we found to be the square root of 3. Actually, we just put H first. So it's S squared times H. So the base is a square, and the volume and the area of a square is S squared. Now I substitute in all my givens. So volume equals 1/3. All right, my computer just froze. Volume equals 1/3, and S squared, the side is 2, times the height, which we found to be the square root of 3. So the volume equals 1/3, 2 squared is 4, times the square root of 3. So my volume is going to be 4 square root 3 divided by 3. Units, because there's no measurement here. Units squared. No, it's volume. Units cubed. Okay, number 7. What is the length of the chord of the sphere shown below? Okay, so for starters, you need to know what a chord is. And no, if we're talking music, then it'd be a group of notes played at the same time. But we're not talking music. A chord, in this case, is a segment where the endpoints both are on the edge of the circle, or the sphere, in this case. So let me show you what I mean. This is our there. That orange line right there is a chord. So it's asking what the length of this is. Well, this is a right triangle, and this is 11 centimeters. So this, from here to here, is a radius. And from here up to here is a radius. And what do we know about the radii of a circle, or in this case, a sphere? Well, the definition of a radius is the distance from the center to the edge. And the distance from the center to the edge anywhere on this sphere is always the same. So if this is 11 centimeters, then this is 11 centimeters. Okay, so now we have a right triangle. So all we have to do is the Pythagorean theorem. A squared plus b squared equals c squared. A is 11. B is also 11. And c is our chord. 11 squared is 121 plus b squared. Whoops. Why didn't I put 11 in for the b? Okay, so this should be 11 squared as well. So 11 squared is 121 equals our chord squared. 121 plus 121 is 242 equals c squared. So therefore, if we take the square root of both sides, then we get c equals the square root of 242. It says give an exact answer using a square root. So centimeters. It's a length, remember, so it's not squared or cubed. We're not talking volume, we're not talking area, we're talking length. So the chord is the square root of 242 centimeters. And how about a recap of how to simplify a radical? So if I took 242 and made a factor tree, and take the smallest prime number out of it, which is 2, then I'd get 121. 121 is a perfect square. That's 11 times 11. And remember, the square root, the index is a 2, so that tells me how many factors I need inside the square root to take outside. So that's 11, and then we take the square root of the remainder, which is 2. So square root of 242 is 11 square root 2. And to prove that, I can show you on the calculator. Square root 242 equals a decimal 15.55. And if I take 11 square root 2, I should get 15.55. So notice these two numbers are equal. So the square root of 242 is 11 root 2. Number 8 says, what is the length of the chord in the sphere shown below? Okay, the sphere is right there, and the chord is the distance from one edge of the sphere going through its center or its interior to a point on the edge again. That is the definition of a chord. And give an answer give an exact answer using square roots. So again, this is the Pythagorean theorem, and this is a radius, and this is a radius, therefore that is 4 inches as well. So a squared plus b squared equals c squared. 4 squared plus 4 squared equals our chord squared. 16 plus 16 equals our chord squared. 32 equals our chord squared. Take the square root of 32 take the square root of c squared, and we get c equals the square root of 32. The square root of 32 simplified is 2 times 16, and 16 is a perfect square of 4 times 4. There's my perfect square, and that would be 4. 2 4s make one outside, and the leftover goes inside. So it's either 32 square root of 32 or 4 square root of 2 inches. Number 9. What is the volume of the sphere shown below? So here we are given the chord length of 20. So this is our given. We know the length of the chord. What we don't know is the radius. And the radius is here, but the radius is also here. So those are equal. So if this is r, this is also r. So I need to find the radius in order to find the volume, because what is the volume of a sphere? Well, the volume of a sphere is 4/3 pi r cubed. So what do I need to know to solve this? A radius. Do I know the radius? Not at the moment. Can I find it? Yes. So I'm just going to let this sit here for a minute. Then off to the side here, I'm going to do the Pythagorean theorem. A squared plus b squared equals c squared. A is r. We don't know it. So the radius squared plus the radius squared equals 20 squared. Okay? Radius squared plus radius squared equals 2 radius squared equals 20 squared, which is 400. Divide both sides by 2. This cancels, and I get r squared equals 200. Take the square root of r squared. Take the square root of 200. And r equals the square root of 200. Okay? But 200 is 100 times 2, and the square root of 100 is 10. So r equals 10 square root 2. Okay? And if you don't understand what I'm saying there, it's my factor tree thing again. 2 times 100, and 100 is 10 times 10, and the pair of 10s goes here, and the leftover goes under the radical. Okay? So that's where that came from. So r equals 10 square root 2. So now I can bring that over here. Now I can do this part. Volume equals 4/3 pi, and my r is 10 square root 2. And we're going, ooh, that was cool. Wow, neat. How do I stop it? Fuck. Okay, I tried to hit pause on the video, but that didn't happen. My computer's being wacky, so one moment. Okay, so volume equals 4/3 pi times 10 square root 2 to the third power. So volume equals 4/3 pi, and this 3 gets distributed. So 10 cubed is 10 times 10, which is 100, and 100 times 10, which is 1,000. And 2 square root of 2 times the square root of 2. Let me do that over here. Square root of 2 times the square root of 2 times the square root of 2 is what square root of 2 cubed means. And the square root of 2 times the square root of 2 is 2, and then times square root of 2. So then if I have 1,000 from 10 cubed times 2, well, that'd be 20, or 1,000, then that would be times 2 is 2,000. So volume equals 4/3 pi, 2,000 times the square root of 2. And if I simplify this, 4 times 2,000 is 8,000 pi root 2 divided by 3. Okay? And if I take my calculator and see if 8,000 is divisible by 3, I see that it's 2,666 and 2/3, so I'll just leave it like this. So this is my answer, and I just need to put centimeters cubed. So my answer is 8,000 pi square root 2 over 3 centimeters cubed. It says give an exact answer using a square root. Done. Okay, number 10. What is the volume of a sphere? So the first thing I'm going to do, okay, my computer's really wacky. I'm going to have to reboot. Volume equals 4/3 pi r cubed. Again, I don't know the radius, so I have to use the Pythagorean theorem, a squared plus b squared equals c squared. I don't know my radius, so that's a and b, and c is 12. So 2r squared equals 144. Divide both sides by 2, and r squared equals 72. So therefore r equals the square root of 72. And 72 is 36 times 2, and 36 is a perfect square, so r equals 6 square root 2. Okay, if you don't understand that, then I'll do my factor tree over here and show you. 72 is 2 times 36, and 36 is 6 times 6. So 6 times 6 is 36. The square root of 36 is 6, and then the square root of 2 stays there. Okay. So r is 6 root 2. So now I plug that in here. So the volume equals 4 over 3 pi times 6 square root 2 to the 3rd power. Simplifying that, we get 6 cubed is 6 times 6, which is 36 times 6. So I'll just use my calculator for speed. 6 to the 3rd power is 216. Square root of 2 cubed is, right here, 2 square root 2. Okay, so now I just multiply all of this, and the volume would be 4 over 3 pi, and 216 times 2 is 432 square root 2. Well, 4 and 3 is 7, and 2 is 9, so 3 will go into this evenly. So I'm going to reduce that, so it's going to be 4 pi. 3 will go into 4 once with a remainder of 1. 3 goes into 13 4 times with a remainder of 1, and 3 goes into 12 4 times. So 432 divided by 3 is 144. So the square root of 2 is still there. The numerator that was here is still there. Now I just multiply those two and we're done. So the volume equals 4 times 4 is 16. 4 times 4 is 16, plus 1 is 17. 4 times 1 is 4, plus 1 is 5. So it's 576 pi square root 2. Or 576 square root 2, and then pi here. Either way, it doesn't matter. And the volume, it is millimeters cubed. So this is our final answer. Okay, that is the end of lesson 19. Review the lesson summary and go do your problem set.